Today in class we did rate mechanism, and so if you were absent, hopefully you're watching this to catch on. I did upload this Word document that has the notes, and I highly recommend that you look through the vocabulary words and kind of understand the vocabulary. First, all reaction mechanism is just a series of steps that the reaction goes through. The example that I gave in class is we've been looking at the reactants always go into the products, and we haven't really seen things that go on in between, like behind the door type thing. The example I gave, if you got up this morning and then you came to school, that would be the reactant, and the product would be the fact that you came to school. Reaction mechanism actually is looking at all those individual things that might have occurred between the point that you got up and you came to school. And so maybe you ate breakfast and you brushed your teeth. All those individual things is what a reaction mechanism is looking at all the in-between little steps. They're called elementary steps. So looking at those individual steps. We have something called an intermediate, and an intermediate is something that actually formed in the middle of one of the steps, and then it got consumed, so it was never there in the beginning, so it was never a reactant, and then it's never there in the end, so it's not a product either, so it's never there in the beginning and never there in the end. It just some point formed and then it disappeared. You can have 1, 2, 3, 4 intermediates in a reaction going on. And then the term molecularity is talking about how many molecules are actually colliding. If you only start in your elementary step, if there's only one reactant, then it's called unimolecular. If there are two, then it's called bimolecular. If there are 3 or more, it's called termolecular, not trimolecular. It's called termolecular. And so we're going to look. Unfortunately, in a Word document, it's not as friendly as PowerPoint, so when I scroll down, things happen differently. So hopefully maybe you print this out and you can follow along. Here's our sample problem. If we were looking at this reaction, this has 2 elementary steps, step 1 and step 2. It says describe the molecularity of each step. In this case, step 1. Since there's only one O3 molecule, which is called ozone, that's what we have in our upper layer, the ozone layer. It makes it O3 molecules. There's only one molecule there, so this is called unimolecular. As simple as that, unimolecular. And then we've got step 2. Step 2 actually has an O3 molecule and an O molecule, so there are 2 molecules here, so this is called bimolecular. Very easy, but people do miss this on the quiz. Alright, the next one is B. It says write a rate law for each step. Now when we do elementary steps to find the rate law, we don't have to do any of that fancy stuff with the graphs or experiment 2 or experiment 3. All we simply do for step 1, I'm going to have to erase this over here. I'm going to run out of room because I'm in the Word document. You simply look at the reactants. Reactants are all that is going to be in a rate law. And so you would simply write rate equals, we don't forget there's a K, and then it's just this reactant. And to figure out what power he gets raised to, it's how many of them we have, or the coefficient. In this case it is a 1, so it would be raised to the first power. And first powers we typically do not write the 1, but I'm going to write the 1 just for we won't forget. That's what we wrote it. So for step 2, it's rate equals K. It is O3 raised to the first power and just O raised to the first power. And that's as simple as that gets for each step. You cannot do that for the overall, but for each elementary step, that's all you do. Now, letter C I'm going to actually do up here because I'm going to be lazy and don't want to rewrite it. All you do for the overall reaction is you just combine step 1 and step 2, and you cross out things that might be on the reactant and product side. Here's an O3 molecule and an O3 molecule, so this is going to make 2 O3 molecules. And I'm not going to write the gases because I'm being lazy right now. Do you see how there's just an oxygen here on the reactant side, and here's an oxygen on the product side? Those two will cancel each other out. and then you're going to end up with 3 O2 molecules here. So basically the overall, what really happens is 2 ozones will break down and make 3 oxygens. So that doesn't sound bad, but the problem is ozone helps us from UV light and oxygen does not. So when we get holes in our atmosphere, we get cancer, and that's what's happening with ozone or ozone layer. But here is the rate mechanism, meaning the steps that it goes through in order for that to happen. This is the way we've been writing it. So that's the answer to letter C. D says identify intermediates, if any. Intermediate would be it got made in one step and consumed in another, so it became a product first and then a reactant. So there's only one intermediate in this case, and it so happens to be just oxygen. If you want to put oxygen gas, you can put oxygen gas. So there's sample problem number 1. So I'm going to have to go back to the Word document and scroll down to do number 2. To do number 2, it's got a little bit of different stuff to it. It's got an extra question on it, and it's got this slow and fast stuff written down here. And that's going to mean something to us, so the slow and fast stuff. So the molecularity for each step, for step 1, it is 2 molecules, so this would be called bimolecular. And for step 2, there are 2 molecules, so this is also called bimolecular. For the rate law, for step 1, it would simply be rate equals K, and it's NO times to the first times NO to the first, because they're both the same. So this would actually be NO2 to the first, NO2 to the first, which would simply be NO2 squared, because it's this one times this one. And for step 2, its rate equals K NO3, which is not nitrates, nitrogen trioxide, doesn't have a charge, times CO. So simple as that. For C, again, I'm going to go up here and write it up here. We've got an NO2 and NO2. There's 2 of them, and there's 1 over here. So one of these actually is going to cancel out, leaving NO2. Here's an NO3 and an NO3 canceling, so that's going to completely go away. And then you've got NO plus CO2. So there's my answer to the third step. For the overall. Sorry, not the third step, but the overall. It should be a balanced equation when you get done. Letter D says identify any intermediates. It could be plural. In this case, it's just NO3. It's not NO2, even though I marked them out. Notice in the overall, NO2 is actually a reactant. So your intermediate cannot be a reactant, and it cannot be a final product. So therefore, it can't be there in the beginning. It can't be a reactant in step 1, and it can't be a product in step 2. So that's the way, or the further step. So there's my only intermediate here. Now this is what it says, determine the rate law for the overall reaction. Now unfortunately you were absent, so you missed a little demo then that I did, but you can only be as fast as your slowest step. Okay, and I guess a good example, some of you do cross country or know about cross country, but there's a team on cross country and there's 5 that run for the team score. So you could have some really, really fast first runners, first one being the first place and then second place, third place, etc. But if your 5th man on your team is number 400, if he's in the last place, you get a cumulative score. So you can only be as fast as your slowest step or your slowest player here. So even though this second step here is very, very fast, since our first step is slow in making its products, this fast step can't go any faster. An example, maybe you're wanting to go really fast on the highway, but this car with grandma in it gets really slow in front of you. You're not going to be able to go fast because the person in front of you is really, really slow. And that's what's happening here. So the overall rate law here is actually governed by what we call the rate determining step. And the rate determining step is the slow one. And so this one, this is our law, this is going to be the answer to the overall. And notice, it does not match our overall equation. Sometimes it does, sometimes it doesn't. You can't count on it to match this. So this one it does not match. So this is the answer to our second sample problem. Our third sample problem going to answer those same questions. The step 1 is going to be, there are 2 particles, so this is bimolecular. Step 2 is also bimolecular. The rate law for each step for this first one would be rate equals K. It would be an NO times an NO, which makes an NO squared. This was step 1. For step 2, it would be rate equals K times NO2, O2 times Br2 to the first, rates to the first, both of them. You can put ones or not put ones, so there's my answer to that one. The overall equation I'm going to do up here. This is 2 NOs. These are going to cancel on us. Leave us Br2. This is going to make 2 NOBr. So there's my answer on that one. Intermediates. My intermediate is N2O2, the guy that was formed in the first step and consumed in the second step. And this was my answer for that one. Alright, E. This time my slow step is my second step. Not my first step, but my second step is really, really slow. So I can only go as fast as my slowest step. So you would think that this right here would be our rate law, because it's our second step. But here's our problem with this. You're not allowed, you can have intermediates in these elementary steps, but you cannot have an intermediate in an overall reaction. So this is not the correct answer for this one, even though it is a rate determining step. So if you end up with an intermediate and it's your slow step, you actually have to do a substitution. I'm going to go to pink now so you can see. You go back up and you find where this intermediate was made, and he was made right here in step 1. And what you're going to do is substitute the reactants that made that for him. So rather than, the pink is the right answer here, rate equals K. Rather than write that intermediate, I'm going to substitute the 2 things that made him, which was an NO times an NO, and an NO times an NO makes an NO squared. And then I'm going to put Br2. So again, I substituted the 2 things that made him for him, and that's how this came about. And this is my answer here. And you do that anytime it's an intermediate that shows up in the overall. So if an intermediate is in the slow step, when you go to write it for the final, you can leave it in the intermediate. So that's the correct answer for this one. It cannot be the overall. And that was pretty much the lesson that you missed. We had some graphing. It's getting pretty late. So since graphing is not going to be on the homework assignment that most of you owe me, I will tape the graphing lesson tomorrow. So you can watch the graphing lesson. I did give you a copy of the graphs. It's on the PowerPoint. So if you were not here and do not have that, the quiz that you are missing does not have graphing on it. But your assignment, if you were gone for this lesson, is page 553 in your textbook, number 53, 55, 57, 59, and 60. Those problems. Okay, this is in your book. Number 60 is a multiple choice question, so you're not doing A, B, C, D on number 60. You are figuring out which multiple choice answer would be correct. So I'm going to stop taping now. The only other thing that we learned this day was this PowerPoint, And if you watch tomorrow, I'll go over those graphs because it's getting late and I need to go home. I still will upload the answers to the review. When I get home tonight, I will upload those answers. So hopefully this helps. For those of you that are absent for this lesson, please try to do that assignment, and you do owe me that quiz. Watch tomorrow for the graphing, or just be able to graph. Before I X out of this, what you're going to need to be able to graph for your test, you can go over this, is you're going to have to be able to graph an exothermic graph and an endothermic graph. And we are not doing this at all, so you don't have to worry about the Arrhenius equation at all. And you do not have to worry about the example of that. So on your study guide that I'll give you, if you haven't picked up your study guide, you need to come by and get your study guide. But I have a study guide for your test. There will be several that I'll be omitting because it is to do with the Arrhenius equation. So you guys have a good evening, and I am going home and to make supper. And we'll see you guys later.